So, yesterday we talked about just not proving, but talking about similarity between figures, right? In order to show figures were similar yesterday, we had to focus on all the angles being congruent, and all the angles between the two shapes being congruent, and all the sides being proportional, okay? This is not necessary for triangles, though. Just like we have congruence shortcuts, right? So we use like side, angle, side, side, angle, side, angle. I think I repeated myself there once or twice, but anyway. We have similarity shortcuts for triangles as well, okay? So for example, one of the similarity shortcuts we have is angle, triangle similarity, okay? If just two angles of one triangle are congruent to two angles of another triangle, then the two triangles are guaranteed to be similar, okay? So we're not going to prove that, but that's the idea. If you only know that two angles of one triangle are congruent to two angles of another triangle, you know the two triangles have to be similar. And that's what Justin was kind of arguing earlier with the fact that my two triangles really couldn't exist, and he was right, okay, because the angles were equal. I don't know about that, but okay. So, I am. Example 2, find the indicated length if possible. Okay, letter A, we want to find the length of BE. So if we go all the way over here, here's our two triangles. Now, we first need to prove or show these two triangles are similar, because we're not told they're similar. Okay? So first thing we want to do is, are these two triangles similar?
They are.
Okay, so Chase says they are. Chase, can you tell me how you know that?
Because if you flip the one triangle up, they would be the same exact shape. And they have those arrow things on the one side.
Okay, so what does the arrows tell us?
They're like parallel.
Parallel. So when we have parallel lines, for example, crossed by a transversal here, what do we know about, for example, angle A and angle D?
They are the same angle.
Yeah, they're congruent because they're what? That's right, alternate interior. I don't know. Okay, so angle A and angle D are alternate interior angles. Therefore, they're going to be congruent because we've got parallel lines there. Okay. What other angles here are going to be congruent? Can we identify? Quante? I thought you were raising your hand. CUNY? For the same reason, right?
Are we all at? Calm down, please.
Isn't ACB congruent with CBE?
Okay, yeah, ABC, this angle would also be congruent to this angle because why, Quante? No.
Or they're not
vertical angles. Okay, so actually, yeah, we have all three here. Now, do we need to show all three pairs? No. As soon as you got two pairs of congruent angles, you're done. Okay, so you can go ahead and say that triangle, I'll name the first one here, triangle ABC is similar to triangle. Now, we have to be careful how we name this. I went from A to B, then to C. So where should I start over here? A to B, that's what does that match to over here? A has the single angle mark, so that's going to start with D. And then I went from A to B, D is going to go to... Actually, no, D goes to B as well. If you look here, I went from A, the single angle mark, to the three angle mark, so D, B, and then the last letter will be E. Okay. When you name those similar triangles, be careful how you name them because it's important, right? And that they're similar by angle. Okay.
ABC is congruent to DB.
So careful. You'll notice I don't have the equal sign there. Just a squiggle. So just a squiggle means similar. Similar.
How can you say it's similar?
Because we have angle, similarity there. We have two angles, at least two angles of this triangle are congruent to at least two angles of this triangle, so it's similar. Okay? Now, we're not done yet. That was just like the pre-work. We had to first of all determine if the two triangles were similar. We weren't told they were, so we had to say that. But we still want to find the length of BE. So let me go back to the problem here. Here's BE right there. Okay? So, Adam, how do we set up, excuse me there.
Sorry.
How do we set up our ratio here? What does the x in this triangle correspond to in this triangle?
I want to say 54.
And I want to say, you're right. Okay? So I'm going to scoot this over so we can see. So yes, x here corresponds to 54, but we need another ratio. So x over 54, what's another ratio we can write here? Go ahead, Adam. So we picked
36 over 54.
close. We did x from the big triangle over 54 from the smaller triangle. So we don't want to do then equals small over big. We want to do big over small. So 54 over 36. I really don't like they're using the same exact numbers twice here with the 54s, but so they did.
What would happen if you used 36 over the 54?
Well, you wouldn't get the right answer, and here's why. Because you didn't set it up in the same way that you set up your first ratio. In your first ratio, we did x from the big triangle over 54 from the smaller triangle. And so you need to set the ratio in the same exact way here, 54 from the big triangle over the 36 from the smaller triangle. Okay? So it wouldn't be right, Chase. It just wouldn't be right. Okay? Do you see that? Okay. Adam, you okay with that too?
Yeah.
That makes sense. So it's very important we set up the correct proportions here. But now it's easy. What do we do at this point, Adam?
Oh, now you gotta cross multiply.
Yep. So
2916.
2916, thank you, equals 36x, right? And then divide both sides by 36. 81. Great. Okay. Easy peasy. We first had to establish that the two triangles were similar, though. Okay, if the triangles aren't similar, we can't use these ratios, or we can, but they won't be right. They won't match up. Okay. So that's angle similarity. Questions on that one? All right, let's scoot it up here. Let's take a look at the next one. So question, Chris.
Wait, is this this is the same stuff we were doing, right?
Yesterday. Yep, similar to it. Oh, no, but okay, anyway. Letter B, RT is what we want to find now. If I can scoot it over far enough so you can see it. Yep, letter B, we want to find RT. So we go to our shape here. Now, do we have two similar triangles here? Do we have two triangles here?
Yes.
We do? I see one. There's a triangle. Where's the other triangle?
Oh wait, no, there's two. There's two.
Where?
Just extend the line.
Right, and then there's this one right here, right? That's triangle 2. So we have a smaller triangle inside a bigger triangle, okay? Are the two triangles similar?
Yeah.
Okay, so I see one pair of congruent angles. We need to come up with another pair, though. Where's the other pair of congruent angles? V and U? How do we know they're congruent?
Because it's alternate interior of
Well, that's a good question. I think we wouldn't say they were alternate interior. They would be, Bryce?
Would maybe line VS and UT be parallel?
They would have to be, I think, yes, because we have corresponding angles there, so I think that would make those parallel, and so therefore these two angles would have to be congruent because they're corresponding. Another way, let's go to Khalil and then I'll go to Lamel here. What do you want to say, Khalil? What? Yeah, is that what you're going to say, Lamel? Angle R? Yeah, so guys, angle R, right? Okay, Justin, Bryce, angle R is shared by both triangles. Angle R is shared by this triangle and by this triangle, and so it's going to be congruent to itself, reflexive property. And so we have angle R is congruent there too as well. Okay, so either way, triangle, so we can say that, let's see here, angle RSV is congruent to angle RTU. Okay, it's just given to us. And then angle R is congruent to angle R by the reflexive property. Okay, these are like little mini proofs we're doing here. Okay, and so then we can say that triangle RSV, we'll say, is similar to triangle, how are we going to name the other one? RSV, what does that match to? R, careful,
You go up a little bit.
not RUT, RTU.
Why can't you do RT?
Because you did RSV, R, well then RT corresponds to RS. You see that? We want to make sure it's matching pieces, and that's by angle. Okay?
Do we need only two congruences to prove?
Because it's again the similarity proof is angle angle. So you only need to show two congruent angles, and you've got angle angle. Okay, you're done. But now we can set up our ratios finally. Okay, so we want to find this length here. We want to find this length RT. Okay, I didn't leave myself very much space, but there it is. We want to find that length. Okay.
Why are you doing it 2 times?
Doing what 2 times?
RSU is similar to RSU.
It's supposed to be a V. Okay. Apologies for my handwriting there. So, there's our little miniature proof of why they're similar. The 2 triangles are similar. And so now we're going to set up our ratios here. So there's x. It's the full side RT. So we're going to say x over, and what does the x match to?
The full length of RT.
Yeah, x is RT. What does RT correspond to in the smaller triangle, though?
RV. No, R.
So look at the letters in your similarity statement. RT.
Yeah, RS.
RS, which is 10. So it'll be x over 10 equals. What's another pair that we know? SV is 8. And okay, so they're corresponding. They're congruent. They're corresponding. That's okay. I just want to make sure you're using the right language there. So x over 10. Now, do I put the 8 on top or do I put the 12 on top? Does it matter?
What?
So when I write my next ratio over here, we established that 8 and 12 are corresponding. So does it matter how I write it? Can I put 8 over 12? Can I put 12 over 8? Does it matter?
Of course it matters.
As long as it matches your first.
Okay, so x was a side from the big triangle, 10 was a side from the smaller triangle. So which one's got to go on top over here?
Go smaller and then bigger, so 8 over 10.
Careful, I did x was the big side, so it'd be 12 over 8. That's okay, the right idea. So long story short, order does matter. Once you set up the first ratio, order doesn't matter. You can do x over 10 or 10 over x, doesn't matter. But then once you establish that first one, you've got to do the second one too.
Could I talk to Wolfgang, Adam, and Kennedy real quick?
Yes. Wolfgang, Kennedy, and who was that one?
Adam Myers.
Adam.
Do I have Adam in this class?
Yeah, Adam's here.
Damn, I forgot
He's been in front the whole time.
In our biology class.
Okay, cross multiply. 8 times x is 8x. 10 times 12 is 120. Divide both sides by 8. 15. Okay, is your final answer there. So the length is 15.
Oh, it's 15. Does that mean that V and U is also equal to S and T? And then
Proportionally, they'll be proportional.
V and R is equal to R and S?
They'll be proportional, yeah. Well, they won't be the same. Obviously, you're saying VU is the same thing as RV, but you can very clearly see VU doesn't necessarily have to be the same length as RV there, right? They don't look
No, ST is equal to VU.
Oh, they won't necessarily be the same length, no. And we'll see that. We'll see that later. Okay, but there's 15 right there.
Laughing at me.
Okay. All right, moving on. Let's try, on the next page, please, I'd like you to try number 6. Okay? Yes. Taking the training wheels off, guys. Time to ride your bike. Hopefully you don't skin your knees, okay?
I can't reach the handlebars.
Can't reach the handlebars. Can you ride your bike with no handlebars?
No.
Okay.
You can.
So again, try number 6, please.
Oh, I can't do this.
Try number 6. Okay, well, yes you can. Don't just look at it and give up, all right? That really annoys me. So please read the question, label the thing you're trying to find, try and set up a ratio, okay? I don't want to have to come over there and hold your hand and do it. You guys can do it yourselves. Do not give me that.
I don't know what I'm doing, Mr. Woodlawn. I'm confused.
Try something. Try something. Try.
KOS.
Well, they came in and gave them now.
Oh,
Sorry.
okay.
Yeah.
I'll read it.
What do you say?
I got 8 copies.
Hey, you ripped my card.
I got 2 that,
Okay.
one for the whole.
So again, try and put this up. So you come up with label the side you're trying to find as X.
What page is it?
So if you're gonna follow along, buddy, you can sit there and play video games all day long. You don't have to
Oh.
book open, friend.
Yeah.
That's not a good choice.
Take that.
He can afford this.
Let's try here. Let's try, okay? That's not a bad idea too. Thank you, sir. Okay.
Oh, you could buy
Dude,
film
you
so you
got
can
Mark.
probably drive your car with the battery.
Yeah.
You need to be taller.
Okay, we just not like a small one.
But at least I have legs to drive long enough that.
So we do 6 and 7, you said?
Just number 6. If you want to try number 7 after you do number 6, go for it. Okay.
You got like a smirk.
ED and CB are parallel, so that means that angle D and angle B are.
You can say E and C will be, well, sorry, AED and ACD will be congruent, and ADE and AAB. Yeah, so you can angle similarity.
Okay.
Okay, you definitely want to check to make sure the two triangles are similar first, before you go and start trying to prove, or start trying to answer stuff. All right, Khalil, what do you do there, buddy? Right, so look here, you said X on top, which is the bigger triangle, over 6 from the smaller triangle. So that means then it should be equal to...
There's
over 6.
Okay, then you made a box.
7 minutes.
Right, good job.
Yeah, box you don't get
Yeah,
their register.
It's a little box.
I'll go down with their hand register and counter, they just like, hey, what?
Yep, like if you from somebody like if
I heard that even was not a requirement from Alan.
no, there's like if they do punch you like.
But, these two lines here are parallel. Well, actually, it's pretty easy on the way it's set up. So you do.
People hit long though, people hit long. When people punch you, just dash.
All right, 30 more seconds here. We're going to go over this one. Where's your variable? Just where's like,
Not those turn hold on.
is this 6 over 9 and 9 over 15?
Like, this is 1, 2, 3.
Well, if you're trying to find AB though, how's it going to help you find AB?
Like,
So label AB in your picture as X and then solve.
No, I'm trying to find how.
If you square it up like this, it's gonna hit them.
Sorry?
I'm trying to find how he was.
Oh, that hurt me more than
Oh, that angle. You have parallel lines here, just, it's the transversal, crossing the.
I know, I put it-
So we
I put it
corresponding
about-
angles.
I'm not waiting for it to like.
We have parallel lines here, crossing the transversal, so again,
Like this.
angle. Two congruent angles.
If I was on, if I was on, I would have done that.
Yeah.
Did you get an extra 6 and then
People I threw up my shoulder. I was doing, they're kind of just, I was like, even now.
All right, folks, let's take a look here.
I saw them, I'm at the park, and like, there's a whole, apparently, like, they said that, call me and you and walk away.
Yes.
Like, I was parked.
All right, E-Chef. Did you get to these two triangles are similar?
Unless, like,
Yes, okay. What congruent angles did you see here then?
ED and CMB.
Okay, so E is congruent, not to D, E and C are going to be congruent, right? Because they're kind of corresponding positions. We have parallel lines. Oh, sorry?
I said D and B.
D and B as well, yeah. So ED is parallel to CB, and so that means this angle here will be congruent to that angle there. Same thing, angle D and angle B will be congruent. Now, I'm going to name those using 3-letter names, so I'll say angle AE, AED, okay, is congruent to angle ACB, okay, because they're corresponding angles. Okay, sorry, I'm trying to see if I can scoot that in some. There we go. Okay, likewise, angle ADE is congruent to ABC, angle ABC. And again, for the same reason, I'm just going to abbreviate here, corresponding angles. And so therefore, triangle AED is similar to triangle ACB. By angle, yes.
Can we say that angle A is congruent to angle A?
Yeah, you can use reflexive property there if you wanted to. Yep, not a problem. Yep, so there you get angle similarity. Now, we're not done yet because now that we've shown the two triangles are similar, we need to find the measure of AB. All right, so AB, that is from here to there, right? So now what is the proportion that we can set up here? Let's go to someone we haven't heard from yet.
Justin.
Wolfgang. Okay, so Wolfgang, this X, right, this full side here, X, what does it correspond to in the smaller triangle? Shh, guys, listen up, please. Yep, sure, the big triangle here, right, X is the full side of the big triangle here, side AB, right? What does that X correspond to in the smaller triangle? What does AB match to in the smaller triangle? AD, yeah, so 6. Okay? So we're going to write X over 6 equals, now we need to come up with another ratio. What's another ratio of sides that we know?
15 over 9.
So, right, 15 over 9. Do you see that there, Wolfgang, though?
Yeah.
The 15 and the 9? And you understand why we had to put the 15 on top. The 15 is the full side from the big triangle, just like X was a full side from the big triangle. And so since you put X on top for this ratio, the 15 has to go on top for the other ratio. And then 9 from the smaller side, from the smaller triangle, so that goes on the bottom, just like the 6 from the smaller triangle goes on the bottom. So we cross multiply and solve. We get 9x equals 15 times 6, 90, thank you. And so then X is going to be 10. Okay, so X is 10. I kind of went into number 7 there a little bit. There it is. X is 10. Questions on any of that? All right, did anyone try number 7? Mr. Wood's like, it's optional. Sometimes I don't even do the ones Mr. Wood asked me to do. I'm definitely not going to do extra work. Okay, so I understand. Hashtag, yeah, at me, right? Okay, so anyway, so there's
What does that, say you crossed out?
what does it say that I crossed out? Oh, 9 divided by 9. We divide both sides by 9. Just solve the equation. That's all you're doing. Okay. These two triangles are similar. Okay, I'm going to show this one to you just because, all right, I think it's important. These two triangles are similar, right? We have P and T are congruent, and they both have right angles. That makes the two triangles congruent. Sorry, the two angles congruent.
How do you get 9 divided by 9?
Chris, it's simple. You have x over 6 equals 15 over 9. You cross multiply and then just solve the equation. Don't worry about trying. So I think what you're running into here is you're just literally just copying down without thinking about it. Try writing down this and then solving it like you normally would, and it'll make sense to you if you do it. If you just do the problem, okay? And then if you have further questions, I'll be happy to answer those. But actually try just doing it and see what you come up with. Okay? PQ, we want to find this length right here. Okay, now this is weird because PQ is not a full side of either of the triangles. Okay. So let's set up. It's exactly right, see? Yeah, see? Yeah, you did. Good. I knew you would if you just tried it there, okay? All right. What is the 12 in this big triangle, right? What does this 12 correspond to in the smaller triangle here? It does not correspond to the 15. It corresponds to the 9, actually. Yeah, it corresponds to the 9. So it's 12 over 9 equals, so 12 from the big triangle. Now we need to come up with another side of the big triangle. I don't have any idea what PR is, but what's the length of PS? If this piece is X and this piece QS is 9, what's the full length got to be? And we don't know what's the middle. Not X minus 9. X plus 9, yeah, X plus 9. So this full length is X plus 9 over, and then what does that correspond to? It corresponds to the 15 right here. Okay, so there's the ratio. 12 corresponds to the 9, so 12 over the 9 equals x plus 9, the full side there, over 15, the full side there. Okay? So now we cross multiply and solve here. 180 is 12 times 15. And then distribute the 9 to the x and the 9, so you get 9x plus 81.
Wait, how do you get x?
Because this length of this side here, Chris, is x and 9 together, so it's x plus 9, the full length there.
Oh.
Wait, 9 times x plus 9 is 9x.
Plus 81. The 9 distributes to the x and to the 9. So 9 times
that's
x,
great.
9x, 9 times 9, 81. So continue solving. We can subtract 81 from both sides. You get 99 equals 9x, and then divide both sides by 9. And what's... Yeah, that's right. 99 divided by 9 is 11.
Favorite number.
Is it? Interesting.
You know what?
Okay. So that's the trickiest one that we've done so far, obviously. Question, Chris?
9 times 9 is 81.
Yep. Okay, so we have two other triangle similarities, and that's it. Remember, we had 5 triangle congruence postulates, but triangle congruence theorems. We only have 3 triangle similarity shortcuts. Okay, we have side, side, side to add to this. We have side, angle, side. So if we think about this here real quick, all right, we talked about in congruence. When we talk about congruence, we had side, 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 angle, side, angle, and angle, side, and hypotenuse leg, right? But for similarity, we only have 3 similarity shortcuts. We have side, 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 which is listed over here next to mine. We have side, angle, side, so those two match up. And then we have angle, angle, all right, which is not a congruence. So what happened to angle, side, angle, and angle, side? Yeah, Jay? Yes. If you guys look here, right, angle, side, angle, and angle, side both have 2 angles already. So that becomes just angle, angle then in similarity. That works. So that's why you'll see in similarity we don't have angle, side, angle, or angle, side, because they both are covered under angle, angle. They have 2 angles, so that's all we need. Okay. Side, 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 well, we have side, side, side. Side, angle, side, we have side, angle, side. Okay, but angle, angle covers both these 2. And hypotenuse leg, I'm not really sure. We don't have it. Okay, it's not there. Anyway, so again, side, 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 triangle similarity. If 3 sides of one triangle are proportional to the corresponding sides of another triangle, then the triangles are similar. And likewise, side, angle, side. If you have 2 sides proportional to 2 other sides, and the angles between them are congruent, then you have side, angle, side here. So let's see that in action up here. So letter A, okay, if you look at letter A, and we're just going to do these next 2, and then I think we should be done. Yep, next 2, and then we'll be done. Okay, so letter A, all right. We've got this triangle right here, and this triangle right here. And we want to determine whether the triangles are similar, justify our answers. Okay, so you can see that they both share an angle. So what type of similarity are we maybe going to go for here? Are we going for side, 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 we think? Is this side, side, side?
No,
Why not?
because there are 2 corresponding.
Right, we have 2 angles congruent. If you look, we are missing 2 side measures here, so we won't be able to compare that ratio. So it's not side, side, side. Is it angle, angle? We have 1 pair of congruent angles, but can we tell the other pairs are congruent? No. So it's not angle, angle, so it must be side, angle, side. So, Lamel, is that what you're going to say? Side, angle, side, that's right. So, Lamel, can you set it up for us? What are the ratios here we're going to check? So, for example, the 4 here, in this smaller triangle, what does that correspond to down here? What side measure? Yep, so 6. Yeah, MN corresponds to MR, so we'll say 4 over 6. And we want to know, is that equal to... Now let's see here. What's the only other measure of this smaller triangle that we know? Yeah, the 8, that's MP. So say, is that equal to 8 over, and then what does the 8 match to in this bigger triangle? Yeah, MQ, which is the length of what? 12, yeah, 8 plus 4, 12, that's exactly right. So now the question is, are those two ratios equal? Well, how can we tell that, Lamel, if they're equal or not? What can you do here? What would you do? Okay, you want to simplify this fraction? You want to simplify the fraction, is that what you're saying? Divide by 2? Okay, so we get 2/3. And how can we simplify this fraction? Yep, 4 you said? Yeah, 4, so we get 2/3. So are the ratios the same? Yes. So the triangles are similar, and I'm going to write it out here. We'll say triangle MNP is similar to triangle, and now that I've named it MNP, how do I have to name this other triangle? MRQ. Very good, exactly right. We went from M up to N, down to P, so M has to go down to R, up to Q like that. So that's your similarity statement. By side angle side, by SAS. Okay. SAS. Right, very good, Lamel. Thank you, sir. Questions on any of that? We're going to do one more here, and I'll give you guys time to start on your homework, okay? All right. Let's look at letter B. Now, letter B, our similarity here for letter B. Does it look like we're going to use angle-angle? Yeah, we have no angles given to us, so we definitely cannot use angle-angle. Could we use side-angle-side? Well, we do have at least 2 pairs of sides, but again, no angles given, so we're not going to use side-angle-side, so the only thing left is side-side-side. Okay? So, Inez, can you match up a pair of sides for me here? And these 2 triangles were at letter B there, the next one on the page 615, the next one down, okay? Can you give me a ratio? Which side has to match to which? So, for example, the 4 here in this triangle, Inez, what does that have to match up to over here? The 6. How'd you know that? You just kind of see it? Okay, and that's true. It's kind of hard to describe, isn't it? Let me give you a little help here. 4, that's the smallest of these 3 sides, right? What's the smallest side in this triangle? 6. So they have to match up. If they're going to match up, it has to be the 4 and the 6. Okay? Can you give me another pair of sides there, Inez, that have to match up? 10 and 15. Very good. The longest side here, 10, has to match with the longest side here, 15. So we'll say 10 over 15. And there's one more pair we have to check. What's the other pair? 8 and 12. Great. Exactly right. So to show whether these triangles are similar, we have to see if all 3 of these ratios are equal. Okay? Now, Inez, how can we go about doing that to see if these ratios are equal? What could we do here? Any ideas? How can we see if this number is the same as this number is the same as this number? Okay, so we could we could divide this by 2. We could simplify the fractions. That's one way to do it. Okay, you could also multiply this fraction by 2 over 2, and you could see it would be the same thing here. Let's simplify it. So yeah, we get 2/3. This fraction we can simplify. They both divide by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. Ooh, that's good. And then 8 and 12, we can both divide those by 4, and again leaving 2 and 3. And so, are these 2 triangles similar, Inez? Mm-hmm. Yes, they are, by side, side, side. So we'll say triangle GHJ is similar. Now, we have to name this other one very carefully here. I'll pick someone else. You're doing a good job there so far, so we'll let someone else give it a shot. Let's go to Zane. All right. If I said GHJ here, Zane, how do I have to name this other triangle?
NML.
So G.
LMN.
There you go. Very good. LMN. Great job. Yeah. G matches to the L, H to the M, and then J to the N. So very good. That gets you your similarity statement. By and there it is. Okay. Questions on any of that?